Hey guys, arithmetic sequences are the topic of our day 2 notes here. And what an arithmetic sequence is, we are going to talk about as soon as we look at this first example here. All right. So it's saying, looking at the example, we want to recall how to write an explicit formula for an arithmetic sequence. But really, let's just look at what it even is. So if it goes 3, 5, 7, 9, 11, you want to think what's happening to get from one term to the next. Well, we're just adding 2 and then adding 2 and so on. So in an arithmetic sequence, to get from one term to the next, we are going to either add or it could be subtract by a constant value, which is called the common difference. And so we represent it with a little lowercase d here. So whatever number it is that you add to get from one term to the next, that is referred to as the common difference. So with this one, we kind of build the pattern. All right, so stick with me here. What I want you to think of is 3 is the first term. So there's a sub 1. 5 is the second term, a sub 2. A sub 3, a sub 4, a sub 5, and so on. All right. So since we are adding plus 2, plus 2, plus 2, that makes D 2. Okay. So when it says, let's create, excuse me, the formula here, we can actually build it using the idea of how do we get from one term to the next. So we start with 3, and then the second term, 5 is really just 3 plus that common difference of 2. And then 7 is 3 plus 2 2's. And then 9 is 3 plus 3 2's. Whoops, squeeze that in there. All right, and then 11, you can argue that you're going to add on 1 more 2. So it's 4 of those 2's, right? Because you're just taking this number, adding another 2, taking this number, add another 2, and so on. So what I'm going to do is start to clean that up. So this is still just 3. Here you're adding on 1 2. Here you add on 2 2's. Here we've added on 3 2's. Oops. And then here we've added on 4 2's. So in general, how we can look at this is to get a certain term in the sequence. You're still starting with 3 every single time. So when we go to write the rule, we start with 3, and then we add on a bunch of 2's. How many of those 2's we add on depends on where the term is in the sequence. So to get the second term, we added on 1. To get the third term, we added 2. To get the fourth term, we added 3. To get the fifth term, we added 4. So the number of 2's that we added on, turns out it's always 1 less than the term number itself. So to get the sixth term, we'd add on 5 of those 2's. So how do we write that in general? Well, if I'm looking for the nth term, so over here, I'm going to write a sub n. It's going to be 3 plus 1 less than that term number would be n minus 1. So we'd add on n minus 1 of those 2's. And so keep in mind, this represents 1 less than whatever the term number is. So that would be the rule for this specific problem right here. When it says, how would you write the same arithmetic sequence using a recursive formula? Well, recursive formula means you have to tell me what the first term is. So you got to give me somewhere to start. So the first term would be 3. And then we could write the rule to say to get any term in the sequence, just take the term before it. So that would be a sub n minus 1 and add on what? Well, you're adding 2 to get from one term to the next. So you would add on 2. That, again, would be the rule for this specific problem right here. But can we take these and generalize them? Of course we can. So when you're looking at it, it says, in general, for any arithmetic sequence, let's take the specifics out. To get a sub n, it's not that you always start with 3. You start with whatever is the first term here. So the first term I can write generically as a sub 1. So we start with a sub 1, and then what we add to it is always 1 less than the term number. So the n minus 1 part stays. But then it was times 2. Think about what 2 represented here. 2 represents the common difference. So when I slide back up, we'd put in times the common difference there. That is the explicit formula. So it's a sub n equals a sub 1 plus n minus 1 times d. Now right here when it says on the CC reference sheet, that means the Common Core reference sheet, right? So you do not have to memorize that one. You just have to know how to use it. So let's just clarify. That is the first term in the sequence. That is what's called the common difference. Those are the two things that you need. In terms of a recursive formula, this is not really something I want you to memorize. I just want you to understand that we would state the first term. So you'd tell me like, hey, here's a sub 1. You know, it's 5 or 3 or whatever number it is. And then if all you're doing is adding to get from one term to the next, you would always say, take the term before it. So that's a sub n minus 1. And then add whatever that common difference is to it. Okay, so this is just simply the term before a sub 1. Right? So that's your general setup for a recursive formula. Give me the first term and tell me to take the term before it and then add in the common difference. Okay, so let's actually take this and put this to good use now. So when I slide down, it says determine if the following sequences are arithmetic. Oops, sorry, I'm a little crooked on the page here. Are arithmetic? If yes, write an explicit and recursive formula. So first you have to figure out, are they even arithmetic? So do they fit that adding or subtracting pattern? So when you're looking at it, you can literally just put beneath it, like, all right, -2, that would be +5 to get to 3. 3 to 8 would be +5. 8 to 14, though, that would be +6. If the pattern suddenly changes, no, then it's not arithmetic. So for arithmetic, it has to be consistent the entire way through. So that means we don't even have to do the second part. Done. Moving on to the next one. All right, on the second page, you've got the numbers 1, 5/4, 6/4, 7/4. It does sometimes help if your numbers are in different formats, like decimals versus fractions versus whole numbers, to try to get them all in the same format to be able to compare easier. So if you think of 1 as how many fourths is that, it'd be the same as writing it as 4 fourths. So I'm just going to write right over that to represent it that way. This way, when you think of what do you have to add to 4/4 to get to 5/4, it would just be plus 1/4. And then same thing here and same thing here. So because it's saying consistent, we would say absolutely, yes, this thing is arithmetic. All right, so there's the first part. And now that it's arithmetic, now you got to do part B. So you have to write it as an explicit formula as well as a recursive formula. So maybe let's break up the page so we have a little bit of space. So explicit, and then over here we'll put recursive. Okay, for the explicit formula, let me just copy the formula from the first page. It's a sub n equals a sub 1 plus n minus 1 times d. What we have to plug in for, we are plugging in for the first term and then also the common difference. So it's sort of like plugging in for m and b when you're writing like a, an equation of a line. You keep the y and the x. Here you keep this part, you keep that part, okay? So the first term, I wrote it as 4/4, but the first term was just 1. And then we'd keep the n minus 1. And then the common difference, well, that's how much it was increasing by. That is your d value right there. So then we can put a 1/4 here. Now, if you want, you can absolutely stop right there and say, that's my answer. So if this was like a show your work question and it just said, come up with an equation, I'm done right there. If it's maybe multiple choice, it may not look like that in the choices. In that case, you might have to clean it up and rearrange it to maybe simplify the way it looks. So just because the 1/4 is in the back doesn't mean that you wouldn't distribute it through. So this would be 1 plus 1/4 n, and then minus 1/4. And then 1 minus 1/4 would leave us with 3/4 plus 1/4 n, like that. Or you could, of course, reverse those, because that would be, the commutative property that you can do it in either order, right? So I would say you can have your answer like this or like this guy. Right? So if it was multiple choice, it may very well look more like that second option there. All right, in terms of the recursive formula, this is our scavenger hunt one. It says, tell me what the first term is, and then give me a rule to get to the nth term. So first term, easy. That's 1. The rule to get to the next term is take the term before it and then add to it whatever the common difference is. So the common difference over there is that 1/4. That's it. That's all you'd have to do. So it's a little faster to write the recursive rule, but it's really not a lot more useful, because now if I said, all right, based on this, go get the 50th term, this is super annoying. You have to find every term between the first and the 50th. Here, I would just plug in the number 50, and it would give me the 50th term on the list. You got one more practice one right here. And so if we try it, we've got -3, -3, -3, and -3. So it perfectly fits the bill that, yes, it's arithmetic. Which means let's do the same thing again. Explicit over here, recursive. All right, same formulas again. A sub n equals a sub 1 plus n minus 1 times d. So if you think, I gave you guys the purple, I think purple was the color I copied it on, the reference sheet. So you can actually look and you'll see it on there. All right, otherwise I'll talk about it in class. So let's plug in. We're plugging in here, plugging in here. First term is 10 plus n minus 1. Common difference is a -3. You just have to be careful, because if you write it as like this, it looks like you're subtracting 3 when you're really trying to say multiplied by. So please put some parentheses around it, or your other option is to put d in front of the n minus 1 there, okay? So this would be perfectly fine. Or if we distribute it, it would be 10 minus 3n plus 3, and so you'd get 7 minus 3n here. All right, so this guy or this guy would be an acceptable answer there for the explicit formula. In terms of the recursive formula, tell me the first term, and then what are we adding to the term previous to the one we want. So first term is 10, and then we would take the term before it, and actually instead of adding 3, we would subtract 3. So that is your recursive rule. So just a few practice ones that are nice to kind of go with. All right, now let's focus on the recursive. So for this one, when it says, where are we at? Given the recursive formula, sorry, my eyes jumped on the page, this, and they're telling you the first term is 5. Can you find the second, third, and fourth terms? Okay, well, absolutely. So if we want the second term, so a of 2, it would be a of 2 minus 1, which is really a of 1, and then plus 3. So if that's my first term, which is 5, you'd put a 5 right here, and then we would calculate. Right? And you can do that for a of 3, and you can do that for a of 4. What I would like as part of the post-video question is I want to know, what are those two terms, a of 3 and a of 4. And then when we get together in class, we'll cover the rest of the question here. So B through C will be our little recap. I just want you to finish part A there. Right? Let's keep moving on to the next page. I like these ones. These are kind of fun to look at. Number 5, slide up here. 5 says, given the first term is 6, and then the fourth term is 18, because that's what that means. A sub 1 is 6, A sub 4 is 18. Are members of an arithmetic sequence. Determine the 20th term. Okay, partially because I'm just a visual person, I kind of like to draw it out. So what I mean by that, the first term is 6, and then I can think second term, third term, fourth term is 18. I'm not going to write all of these guys, but you can kind of dot it. Somewhere down here is the 20th term. So we have to figure out if it's arithmetic, what the heck is the pattern? Are we adding? Are we subtracting? And by how much? All right. So the goal here is we need to find the pattern. So what we're going to use is not this down here, but this initial part. So think about what's happening. To find what that common difference is, you would add something, whatever it is. So I'm going to say plus D to make it generic. To get from the first term to the second, you'd add it on again to get from the second to the third, and then you'd add it on one more time to get from the third to the fourth. So I can basically set up a little equation here. So I can say that if I take 6 and I add on 1, 2, 3 common differences, I should get 18. And by using this, we can quickly solve for D. So subtract 6 from both sides. We get 3D equals 12. Divide the 3 out of there, and it turns out the common difference based on our calculation is 4. So take 2 seconds and make sure that that makes sense. So then if we add 4 here, that would be 10. Add 4 here, that's 14. Add 4, yep, that makes complete sense right there. Once you figure this out, I don't want you to then just keep adding 4 to get to the 20th term. This is where I'd want you to now use an explicit formula to solve for that guy. Because like I said, we're not trying to, count on our fingers here. We want to be able to use equations, use formulas, and be smart about this. So we know the first term is 6, right? And we found the common difference. It's 4. We are perfectly set up to use that explicit formula. So let's write it first. So a sub n equals a sub 1 plus n minus 1 times the common difference of 4. There you go. That formula will now find any term we want. And the term we want is the 20th term. So if I want a sub 20, all that really means is let's plug in 20. That's it. That's literally all we do. So take 6, plug in 20 here, and then times 4. So it really means you're taking 6 and adding on 19 4s to it. So if you grab your calculator, or you can mental math it if you're feeling it, and we would just do 6 plus 19 times 4, and our 20th term then should be 82. So way down here on the list, that should be 82 right there. Ta-da! All right, the next one, similar type question. So let's set it up the same way. It's saying you have the 8th term and the 10th term of an arithmetic sequence. Again, that's important because you can't just assume that you're adding from one to the next. And we'll see in the future that there's different types of sequences as well. We want to find the 16th term. So because they didn't give us the first term, I'm going to kind of say, here's a sub 1. Come along here. Here's the 8th term. It's 15. There would be the 9th. There's the 10th term. And then way down here, they want us to find the 16th term. That's what we're looking for. All right. So I still want to set it up in a similar fashion to think like, what are we adding to get from here to here? So I would add the common difference from here to here. So 15 plus 2 of those common differences will land me at 30. And we can easily solve this. So 2 times D equals 15. Cut that in half. That means the common difference would be 7.5. Now, for a question like this, there's multiple ways that you can finish it. Right? So we could work backwards to figure out the first term, but something that I want you to keep in mind, you don't have to set it up like that every single time. So instead of thinking of the explicit formula as saying that to get to the nth term from the first term, that it's n minus 1 times d, we can actually adjust this a little bit to make it fit what we have. So if I want to get from the 10th term to the 16th term, then what I really could do is I could say, all right, I want the 16th term and I know what the 10th term is. How many of those common differences do we have to add on to get from the 10th term to the 16th term? Well, I could kind of count. I could go, 11, 12, 13, 14, 15, 16. Or what I can think of is it's however many terms there are from 10 to 16. So you can actually take that difference right there, right? So let's fill in what we know. I know it might seem a little strange, but we're looking for this. Right now, we know this number's 30, and we have to add on 6 of those common differences of 7.5. All right, well, let's do it. So let's take 30 and add on 6 times 7.5, and we're saying that that should bring us up to 75 right there. So are we certain? Well, you could always take your calculator and then say plus 7.5, so 7.5. It wouldn't take too long to check. It's not necessarily the way I want you to solve it to begin with, especially because I could ask you for like the 50th term, but otherwise, could you at least check for when the numbers are fairly close together? Sure, you definitely could. So what this kind of brings up is if you know the first term. Oh, sorry, I jumped past it. If I know the first term and I'm going to the nth term, then I would do n minus 1 in the parentheses here. But if I don't have the first term, then all I have to do is kind of monitor and adjust a little. I would take the difference between those two subscripts. So that's what's going on down here. So when it says if you don't have the first term, what can we do? Well, to get from the 5th term to the 9th term, we would just add on whatever the difference in those little subscripts are. So to go to the 5th to the 9th, it's just 9 minus 5, or 4 common differences. Right? If you have the 8th and the 15th term, how many common differences between those? Well, 15 minus 8, there'd be 7 of them. So you don't have to figure out what the first term is always. You can kind of take what you have and work with it. So to write this generically, if you're given the a sub x term and the a sub y term, then to go from the x term up to the y term, what would go in here is whatever the difference between x and y is. So y minus x there. We have one last page, and I want to look at just the top question. So the top question, number 7 here, says there's 19 seats in the row nearest to the stage of the theater. Each row after the first row has 2 more seats than the row before it. How many seats are in the 13th row? How many seats are in the 20th row? All right. It doesn't have to be an amazing drawing, but just kind of sketch what's happening here. So maybe here's your stage. And it's saying the first row has got 19 seats. So here's 19 seats. Each row after the first row has 2 more seats in it. So then that would be, 21 and 23, something like that. When it says how many seats are in the 13th row, so we're looking for what's a sub 13. How many seats are in the 20th row? That would be find a sub 20. All right, so you can take this word problem and turn that data right into an arithmetic sequence because it's going up consistently by plus 2, plus 2. Right? So if I think of my first 3 terms are these guys right here. And the fact that it goes up by 2, that's your common difference. So when we think of the explicit formula, so let me just remind you that that's what this is a sub 1 plus n minus 1 times d. Write yourself a formula first. It's 19 plus n minus 1 times 2. And now it's useful to go write a general formula first, so that then I can use it to find multiple things here. So now the 13th row would be 19 plus 13 minus 1 times 2. And when we calculate that out, that means I'm going to end up with 57. So in the 13th row, there would be 57 seats. All right. And then in the 20th row, now just change what you plug in. So it's 19 plus 20 minus 1 times 2. Right? In that case, Oops, I'm so sorry. I misread my little notes over here. I was trying to shortcut and I looked at the wrong answer. Just joking. That first one should be 43, in case you were thinking that didn't seem right. When you plug in the second one, wild guess what that turns out to be. This would be 19 times 2 plus another 19. This is the one that gives us 57. Sorry about that. So then in row 20, you would have 57 seats there. All right, number 8. We'll save that guy for class. Go answer that post video question right now. Thanks, guys.